Greetings and welcome to the graphics class. Question number 11, isometric projections. A sphere of 20 mm radius is placed centrally over a hexagonal slab of side length 25 mm and thickness 20 mm. Draw isometric view of the combination. We have to start with the simple position because there is no need of isometric scale. How to draw the simple position? There is a hexagonal prism. It is mentioned as hexagonal slab since the thickness is small compared to length of the side. So we will start with a hexagonal prism. This is the base. Okay, now I am going to draw the front view of the prism. Okay, the front view is also drawn. I am marking it as A1, B1, C1, D1, E1, F1. Correspondingly, I will get F dash, A dash, F1 dash, A1 dash, then E dash, B dash, E1 dash, B1 dash, then I will have D dash, C dash and D1 dash, C1 dash. Okay, this is the simple position of the hexagonal prism. Using another color, I am going to draw the sphere. There is first of all you have to find out the center. After finding the center, taking this as center of the circle, the radius is 20 mm, it is given. Based on that, you can draw the circle. Using actual dimensions, if you draw, you will get a circle inside the hexagon. Inside the hexagon. Okay, the same circle we can draw at the top of the prism. Okay, then also you are drawing, this is 20 mm. Okay, so this height is 20, that is from the base to the center it is 20. So I am marking this point as say C, and let this be M, like in the last problem. Now this distance is 25. This distance is 25. Sorry, that distance is actually 20. That distance is 20, and this distance is 25. This distance is 25. So this is the simple position of the solid. Using the simple position, you have to draw the isometric view. For drawing the isometric view, since it is a hexagon, you need a box. So the next step is to have a box through the extreme ends of the hexagon. As usual, we will name it as W, X, Y and Z. X, Y and Z. I think it is clear to you because this procedure we have done for many other prisms or pyramids. Next we are going to draw. Using the simple position, we will draw the isometric view. For drawing the isometric view, as usual, we can have the isometric axis. They are inclined at 30 degree to the horizontal, or we can say they are mutually inclined at 120 degree. We will fix any of the corner from this box. So we can fix Z here. So now you measure Z to W. You can mark that distance along this axis, Z to W. So let this be W. From W, you can draw WX, the distance WX, parallel to this isometric axis. Okay, this distance we can mark here. So this is WX. So parallel to this isometric axis, again you can have another line. Okay, so this is WX, Y and Z. Now you have to mark each and every point of the hexagon, corners of the hexagon along this box. So you can measure WA or WA1. So you can mark A1 here. Then Z to F1 you can mark. So F1 can be marked here. Then you will get B1 as the midpoint of WX. So this is B1. Then X to C, C1, you can measure. This is C1. Then Y to D1, you can mark. Then you will get the midpoint of YZ, which is E1. After getting this, we can take the height of this slab. The height of the slab is 20. From each point, you can have 20 mm height. So from A1 you have drawn. The same height you can take from B1. Okay, the same height should be there. Then from C1, you are using the height C1. Then from D1, E1, the same height you are taking. Then F1. Okay, so you can mark this as A, B, C, D, E and F. You can join these points. So A to B, B to C, C to D, E to E, E to F, then F to A. So the hexagon on top is also now ready. Now you have some more lines, that is A1, B1, then B1 to C1, C1 to D1 already there, then D1 E1, E1 F1 and A1 F1. Okay. Anyway, now we will concentrate on this particular top base. Okay. So using the top base, we have to place the sphere on top of this. How to do that? You can join A to D, the diagonal. Similarly, you will get B to E, another diagonal. So now you are getting this as the midpoint. From there, you can measure 20 mm, which is the radius of the sphere, because the sphere is in contact with the surface at this particular point. That point can be marked as M. That point is marked as M. From M to this C, from M to C, you are having another C here. I am keeping it here. Now from M to C, it is 20. This measurement you can take here. So this part is 20, and point C, which is CM. CM is this much. So here also you are marking that. The height is 20 itself. Actual 20 you are getting. Now you have to draw the sphere on top of that. How will you get the sphere? The radius of the sphere should be iso radius Ri, which is equal to 1.225 times that of the actual radius, that is 20. So the next radius which you are going to take is actually Ri. Up to here it is the actual dimensions. Now only you are going to take Ri is equal to 1.225 times that of R. You calculate that and take C as center, Ri as radius. You draw the circle. Okay. Now it is very clear that it is going below this diagonal, or it is going below the point M. That is, even though the contact point is M, you feel that the sphere is touching the surface below M. Like that you will get a feel in isometric view. Now it is very clear. Now we will check the visibility. How to check the visibility? All the outer edges are visible, isn't it? So A1, A is visible. Now AB is visible. B2 up to this sphere it is visible. Then from the sphere up to D it is visible. D1 is visible. D1 E1 is visible. E1 F1 is visible. A1 F1 is visible. Now the top surface of the I don't know, outer means you have to get this sphere. On top of that you are having the sphere. The entire sphere is visible, or entire circle is visible. Okay. Now the top base, avoiding the sphere, the remaining part of the top base is visible. That is, A to F is visible. A to F is visible. F to E is visible. E to D is visible. Now you are having the edges which are nearer to the observer. They are E1, it is nearer to the observer. F1 is also nearer to the observer. They are visible. This is the visibility. You are having the circle, the remaining portion of the sides at the top base, and all the outer edges. Then the edges nearer to the observer are visible. Okay, now we can conclude. First we have started with the simple position. Isn't it? We have started with the simple position. Based on the simple position, we have started drawing the isometric view. First we have drawn the hexagonal prism or hexagonal slab. After that, using the diagonals, we have found the midpoint. From the midpoint, you have taken the radius of the circle, actual radius of the circle that you have taken. Then you found the point C, or the center of the circle. Then using the center, you have calculated Ri, which is the iso radius, which is equal to 1.225 times that of the radius. Using that, you have drawn the circle. So definitely the circle should go below the diagonal, or below the point M, below the contact point M. You got this particular figure. Now you can practice it.